Okay, boys, class 12. In our last class, we have discussed about types of solids. Particularly, in the first time, you have come to know two types, crystalline solid and amorphous solid. And the next part of the class, you have seen types of crystalline solids. So regarding that, I have already told you that you will go through the tables. You will find a difference between amorphous solid and crystalline solid. And then you will have another table in your NCERT book. There you have seen that the different types of crystalline solids, nature of interactions, and examples. Today, our next it is video class, and you see that crystal lattice we shall discuss here, crystal lattice, unit cell, and their types. Now, before going to this part, let us have a clear picture. A small part of the crystal lattice is here. It is in 2 dimension. In 2 dimension, you can see it 2 dimension, and you have to construct layer after layer above it in order to have 3 dimension. Now see, in the crystal lattice, you see there are some points. These points are known as lattice point. Lattice point. Lattice point. Lattice point actually means a constituent particle of the solid, crystalline solid. Now, whatever we are telling about crystalline solids. Remember it. So, lattice point, each and every lattice point means this is the constituent particle of the solid. Clear? Now, you see that between the lattice points, the space, this is known as interstitial site. Interstitial site. Clear? And this point is known as lattice point or lattice site. Point means position of the constituent particle of the solid. Now, this 2-dimensional figure. So, we see that what is crystal lattice? Crystal lattice is a regular 3-dimensional arrangements. I repeat, regular 3-dimensional arrangement of lattice points in the space is known as crystal lattice. Once again, I am telling, regular 3-dimensional arrangement of lattice points in the space is called crystal lattice. Now, in the crystal lattice, a smallest portion, smallest 3-dimensional block is chosen. 3-dimensional block is chosen, which when repeated in all directions, generates the entire lattice. That smallest portion of the crystal lattice is known as unit cell. So, clear it, the idea, unit cell. What is unit cell? Unit cell is a 3-dimensional smallest part of the crystal lattice, which when repeated in all directions generates the entire lattice. Such a smallest portion of the crystal lattice is called unit cell. Now, the question is that unit cell, how to look, how to see them. Unit cells and their types, you see it here. Unit cells are first characterized on the basis of length, breadth and height, because it is 3-dimension, length, breadth and height. And another feature, structural feature is their axis to axis angle, axial angles, interaxial angles. So, length, breadth and height denoted by A, B and C, length, breadth and height, and axis to axis angle denoted by alpha, beta and gamma. So, on the basis of these two structural dimensions, unit cells are classified. Firstly, what are the dimensions? The dimensions are length, breadth and height, A, B and C, and interaxial angles alpha, beta and gamma. Clear? Now see, you can show it in this way, that is like this. So this is say alpha, this is say beta, this is say gamma. So see, these are the axis alpha, beta, length, breadth and height, length, breadth and height, and interaxial angles alpha, beta and gamma. On the basis of these two dimensions, unit cells are found to be of 7 types. How many types? 7 types. 7 types. So these 7 types of unit cells are found in the crystalline solids family. Clear? 7 types of unit cells are found to exist. Found to exist in crystalline solid family. These are namely 7 types. The types are number 1, cubic crystal system, cubic crystal system. Number 2, hexagonal crystal system. Number 3, orthorhombic crystal system. Number 4, tetragonal crystal system. Number 5, rhombohedral or trigonal crystal system. Number 6, monoclinic crystal system. Number 7, triclinic crystal system. So you see, 7 types of unit cells are found with these variations, variation in alpha, beta, gamma and variation in A, B and C. We have total 7 types of crystal system. Cubic crystal system, as you know, the characteristics feature of cubic crystal system is A equals to B equals to C, alpha equals to beta equals to gamma. You know it. So in such a unit cell in which the length, breadth and height, they are all equal, and alpha, beta and gamma, the interaxial angles are all equal and it is equal to 90 degree, then you will say that the unit cell is cubic unit cell. This is the cubic unit cell, primitive unit cell, cubic unit cell. Now see, on the basis of these variations, say in hexagonal crystal system, A equals to B, but not equals to C. A equals to B, length equals to breadth, but that is not equal to C. Height is different. And alpha equals to beta equals to 90 degree, but gamma equals to 120 degree. Gamma equals to 120 degree. So such a structural features, if you observe in the unit cell, then it is said to be a hexagonal unit cell. Alpha A equals to B, length equals to breadth, but height is different. Alpha equals to beta equals to 90 degree, but the gamma, this is equal to 120 degree. So on the basis of these variations, there are 7 types of crystal systems are found. Now, you are instructed to write the variations in case of orthorhombic, in case of tetragonal, in case of rhombohedral, in case of monoclinic, in case of triclinic, as well as the examples. Examples you will see. There is a table in the NCERT book. You will find these crystal systems and their variations and the example. Say for cubic crystal system, the example is sodium chloride, zinc sulfide, example, which have cubic unit cell. In hexagonal crystal system, the example is graphite. You know, it's a very well known allotropic modification of carbon, graphite, which is having hexagonal unit cell. So you will see you are instructed to prepare from your NCERT textbook. This is a very important thing for competitive exams as well as for our exams. Next, see, but interestingly, after knowing this, there are 7 types of crystal system. Interestingly, you have only cubic crystal system in your syllabus. In your board, for your board exam and also competitive exams, you have a cubic crystal system in your syllabus. Now let us discuss the cubic crystal system. In cubic crystal system, on the basis of the position of the particles, constituent particle, the unit cells are further classified into 2 types. One is primitive unit cell, and another is centered unit cells. So primitive unit cell and centered unit cell. Primitive unit cell, it must be present in every crystal system. I mean, primitive unit cell will be present in cubic crystal system, hexagonal crystal system, orthorhombic crystal system, tetragonal crystal system, rhombohedral crystal system, monoclinic crystal system, triclinic crystal system. This is all the 7 crystal systems. You will have primitive unit cell. Now, what does it mean? Primitive unit cell means the unit cell in which the constituent particles are present only at the corners of the unit cell. That you will see here when I draw the diagram. Primitive unit cell, what is primitive unit cell? It is that unit cell in which the constituent particles are only present at the corners. And now second type, centered unit cells. Centered unit cells, further you will see, these are 3 types, centered unit cell. One is body centered unit cell, another is end centered unit cell, and the third one is face centered unit cell. So unit cell, should I write unit cell in this way? So centered unit cells, on the basis of position of the particle, they are again body centered unit cell, end centered unit cell, and face centered unit cell. I will show you their diagrams, how to draw their diagrams. So first of all, it is make it clear that primitive unit cell means that unit cell in which the constituent particles are present only at the corners. Secondly, centered unit cells, these are that unit cells in which there must be a particle or particles present at the center of the face, center of the body, and center of the face in two opposite faces, in addition to the particles present at the corners. In all cases, in here also, the particles will be present at the corners. In addition to there is a particle at the center of the body. There are particles at the center of each faces, that is face centered. There are particles at the center of two opposite face, a pair of opposite faces. Such unit cells are known as body centered, end centered, face centered unit cell. Let us make it clear with the help of a diagram. Because you have only cubic crystal system in your syllabus, so we shall draw the figures of diagrams of cubic unit cells. Remember it, cubic unit cells. Now see primitive unit cell. Draw this diagram, primitive unit cell. This is a cube, and the particles are present at the corner. This is a particle, particles. This is primitive unit cell. Clear? This is the unit cell, three-dimensional smallest block of the crystal lattice. Crystal lattice which when repeated in all directions, the whole crystal will be generated. Now see, here is a particle. These are the particles. There are 8 corners. Particles are present only at the corners. Now see centered unit cell. Centered unit cell, this figure, first you draw a cube, okay, then you give the position. The particles will be present at the corners. Without the particles at the corners, there will be no shape of the unit cell. So particles will be present, always present at the corners. In addition to that, there is a particle at the center of the body. This is the particle which is at the center of the body. See, it is just at the center of the body. This is a centered unit cell and its name is body centered unit cell. Body centered unit cell. This one is body centered unit cell. This one is primitive unit cell. Primitive unit cell. Go to the end centered. Again you draw a diagram of a cube. Draw it. Then give the position of the particles at the corner first. And then in end centered, take a pair of opposite faces. You know a cube has total 1, 2, 3, 4, 5, 6 faces. So you just choose a pair of any two opposite faces. So it's a face and its opposite face is this one. Just place a particle at the center of the face and center of the face. This one is end centered unit cell. This one is end centered unit cell. Clear? Now end centered unit cell means in addition to the particles at the corners, there are 2 particles at the center of any 2 pair of opposite faces. That is end centered unit cell. And face centered unit cell, draw this diagram first. Draw this diagram. Give the position of the particles at the corner first. Without the position of the particles at the corners, unit cell can't be defined. Remember it. Unit cell, this is the main structure of the unit cell. In addition to the particles at the corner, there is a particle at the center of each face. So this is the face, this is the center, this is the face, this is the center, this is the face, this is the center. Just look at the center and put it. This is the face, this is the center, This is the face, this is the center, this face, this is the center, and this is the face, this is the center. See. Now see the diagram. You draw a cube, put the particles at the corners first, and then look at the face, every face, put the particle at the center of every face. That will be the diagram of face-centered unit cell. Now see, just 1 minute, you see the diagrams. These 4 diagrams are very important. This is primitive unit cell only at the corners. This is body-centered unit cell. In addition to the particles at the corner, there is a particle at the center. In end-centered unit cell, in addition to the particles at the corner, there are 2 particles at the center of any 2 opposite faces. And in face-centered, in addition to the particles at the corner, there is a particle at the center of each face, remember. Now the next point is contribution. How many particle is there? This is a particle, constituent particle. In the corner, a particle which is at the corner is shared by 8 unit cells. 8 unit cell. What see? This is 1 unit cell, another next unit cell, this side next unit cell, this side next unit cell, 4 on the same plane, 4 above the plane. So the particle which is at the corner is shared by 8 other unit cells, 8 other, total 8 unit cells. So contribution of the particle to the unit cell is only 1 by 8. Only 1 by 8. So only 1 by 8 part of the particle will be inside this unit cell and rest with other unit cells. Remember, corner position. So 1 by 8 is the contribution of each particle. There are 8 such particles. So into 8, this is equal to 1. So a primitive unit cell contains only 1 particle. Remember it. A primitive unit cell contains only 1 particle of the solid. Remember it. Now in this case, body-centered, see the calculation, body-centered 1 by 8 into 8 for the corner particles, and there is a particle whose contribution is full at the center of the body. It is inside the center, inside the unit cell. So 1 into 1, that is equal to 2 particles. So in case of body-centered unit cell, there are total 2 particles. Remember it. It is the whole contribution. This particle is fully contributed to the unit cell, and the corner particles 1 by 8, 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 1 by 8. That is 1 plus 1, that is equal to 2. In case of end-centered unit cell, similar calculation you do, 1 by 8 into 8 plus 1 by 8 into 8, the particle which is at the center of the face, half of the particle will go inside the unit cell and another half will be shared by the unit cell which is just above it. So it is a surface, it is the face of unit cell, it is another face of the unit cell. This is 1 unit cell, this is another unit cell. Here is a particle. Particle means it is sphere. So half will go above and another half will go below. So half, contribution is half. So 2 particles and contribution half into 2. So this is also equal to 1 plus 1, that is equal to 2 particles. So end-centered unit cell is composed of, 1 unit cell is composed of 2 particles. One unit cell of body-centered unit cell, 1 such unit cell is composed of 2 particles, and primitive unit cell is composed of 1 particle. Now come to the last one, face-centered unit cell. Calculation is similar, 1 by 8 into 8, 1 by 8 into 8 corner particles plus particles at the center of each face. There are 6 such particles and the contribution is half to the unit cell, half into 6, that is equal to 1 plus 3, that is equal to 4 particles. Now you come to know that face-centered unit cell is composed of 4 particles. So it is most efficiently packed. Most efficiently packed. Rest part is void, some part of the unit cell is void, and some part of the unit cell is packed with the particles. So if you talk about the packing, primitive unit cell, 1 particle only, least packing efficiency. That means least packing efficiency. End-centered and body-centered, and end-centered, 2 particles in each unit cell, their packing efficiency is similar. And most effectively packed unit cell is face-centered unit cell, which is having 4 particles in each unit cell. Now, the contribution we have understood the different types of unit cells on the basis of position of the particles. On the basis of position of the particles, this is classified on the basis of position of the constituent particles. So in case of cubic crystal system, I must say the cubic crystal system, the primitive unit cell you will find, and centered unit cell you will find, body centered unit cell you will find, face centered unit cell you will find. This you will not find in cubic crystal system. Cubic crystal system has 3 types of unit cell based on the position of the unit, based on the position of the particles. They are primitive unit cell or simple cubic unit cell, number 1. Number 2, body centered cubic unit cell and face centered cubic unit cell. You will not find end centered cubic unit cell in our cubic crystal system. This end centered unit cell you will find in other crystal system. So this much is our today's video. You will draw this diagram and practice it, and then we shall go to the next video class. Okay.